Okay, RIP of course, has an open source implementation. It's Zebra, the Zebra project. In fact, the Zebra project not only implement RIP but also implement the other protocols, OSPF and BGP. And it runs as a daemon. Here's its old structure. So you have a Zebra daemon here, and it does the computation. It exchange. If it runs RIP, then it would exchange distance vector with the neighbor routers, and it would also update the routing table within the kernel. And here's a more detailed organization of the Zebra. It has a Zebra daemon. It's more like a super daemon, and then a daemon for each routing protocol. So we got this daemon and also one super daemon, which is a Zebra daemon. So the Zebra daemon, to communicate with the kernel, it has several interfaces to communicate with the kernel. And for the daemon to exchange or broadcast, with neighbor or broadcast through the network, it has a socket. It has a socket interface. By passing the Zebra daemon, it would use a socket interface to communicate with the other routers. So these are to communicate with the other routers. But these are to communicate with the kernel. These are for the Zebra daemon to communicate with the kernel. So, so if I want to exchange routing distance vector or link state, they go through this. And then do the computation. And if I need to update my routing table, I go through Zebra daemon. And Zebra daemon would use one of the interface to update the routing table. And within RIP-D, this daemon process, its computation is done here. I do the Bellman-4 algorithm. I compute the Bellman-4 algorithm here. And if the computation has some result and I need to update the routing table, I go through here. If I need to exchange with my neighbor routers, then I call these functions. Okay, so and a Dijkstra algorithm is implemented here. Sorry, Bellman-4 algorithm. How about OSPF? OSPF is a newer protocol, routing protocol, and it implements Dijkstra, the Dijkstra algorithm, and it's link state routing. It broadcasts the link state, and it supports multi-path routing. It's possible to support multiple paths at the same time, but usually it depends on the administrators whether you need multiple paths. But it has this feature, but although it's not used often. And support TOS-based routing type of service. Support variable subnet length, which is of course supported. There's an extension protocol called MOSPF, which is multicast OSPF. And it leverages the OSPF routing table for multicasting, but we will not cover here. Okay, two-level, and for OSPF, it can also within a domain, it can break down into areas. So if this domain is too big, then I can break down into the domain into areas, and then you would have intra-area routing and inter-area routing. If you do that, so that is used when the domain is too big. For example, this is an area ABC and the backbone area. So you would have intra-area routing here, inter-area routing here, and intra-area routing in each area. But that's only used when the domain is really too big. Even within NCTU, which is a big domain, we don't use areas. Okay, so, and this is an example, a large network with areas, with 3 areas. And then you can have intra-area routing that will render this routing table, or inter-area routing with another routing table. But we don't, and this is a result of an inter-area routing table. If RT4 is RT4 participate both intra-area routing and inter-area routing. So within the routing table, it would have both kind of entries in the table.